Think about like why you're here today. Proximate reason you're here today because there's a conference and you're like, I want to go to it. And so why not? I'll go to this conference. But really why you're here today is probably because you care about crypto. You care about blockchains. You care about these internet computers. I think they're very cool. It's why I left Wall Street 7 years ago to get started in crypto and have been in it ever since. If you care about these, you're doing something to advance their adoption, to increase the demand for them. And what we've learned over these past few years is that whenever we do that, we're putting all of our life energy into increasing the demand for these things, but because of their construction, right? They by construction, they limit digital resources. They make them scarce. We run into problems. We run into the same scalability problems every time. Most common manifestation of them is that the gas gets too high. And so how do we solve this, right? Like we have this problem. We want to get people using blockchains. We spend all this effort. We get them to use blockchains. And then when too many of them use them at the same time, we run into this. And this just happens every single time. It's unavoidable. So the modular ecosystem has presented itself as a solution to the scaling issues of crypto in general. Up until a month ago, if I was giving you a talk like this, what I would be saying is that it's one of two paths, right? That on the one hand, we have something like the monolithic approach, which is I'll build the best, fastest, most performance computer I can, and that would be something instantiated in Solana. And on the other hand, we have the modular approach, which says instead of building one massive supercomputer, I'm going to build lots of little computers, and I'm going to let you easily deploy them, easily manage them. But now I'm convinced that it's actually all the same. Because what we've seen, just this past week and the week before, is that even the supercomputer approach falls prey to the same thing when it is so successful at its job of creating that demand, energizing that demand, it too has these issues. And one thing that I think could have mitigated some of the problems that Solana experienced last week is if it actually had, the thing that many people in Solana ecosystem have mocked, this notion of layer twos. If the stream of transactions was distributed to multiple destinations instead of all coming to the same place in Solana and kind of overwhelming the leader nodes that were working on Solana consensus, probably don't see all the transaction failures that people, myself included, experienced in the last 2 weeks. So now I'm convinced that the modular path is really the only path to scale crypto. And so where are we with respect to this? I would say that we had like the first, the big bang, call it, of the modular ecosystem happened somewhere in Q4. That was originated with the launch of Celestia, bringing us the first like alternative data availability layer, but it has been accelerated, and now I would say we're in the modular expansion phase. And this is made possible thanks to the works of Celestia and EigenLayer and all the roll-up service providers like Caldera and Conduit and AltLayer and Anchor and several others. Also thanks to the great work of people like the Arbitrum team, the Optimism team that have created roll-up frameworks that let you pretty easily build and operate an Ethereum roll-up. And so all of these things have taken down the cost of launching a new chain very, very meaningfully, right? 2 years ago, if you wanted to launch a new chain, even if you were just basically copy-pasting the EVM as the base of your chain, still a massive, massive endeavor. Need a lot of money, need a lot of time. Now those parameters are going straight down, right? And it's thanks to all the work of the people in the modular ecosystem. And so if we're in this expansion phase, like where does it take us from here? Had our big bang. I think what we're going to get to is just more and more and more and more of these rollups, different rollup ecosystems being built around them, then things you could even think of as sovereign rollups, which they have less of a tie to, they will do their settlement by themselves. And so in this world where it becomes cheaper and easier to launch your own rollup, to launch your own chain, where does that leave us, right? And I would say that right now, generally when people talk about the modular stack, they really only talk about these four things. They talk about data availability, consensus, settlement, execution, all the like core components of a singular chain. But in this world, we're just, again, we've said it's going to be so easy to launch your own chain. It already is, thanks to the work of all these people. We're saying that we want to have many of these computers to distribute the load and to allow us to kind of get past the scalability issues that we've had in crypto. Well, if each one of these new chains is an island and is not connected to the rest, it's not connected to any of the mainlands, like what did we do? That too is going to be extremely counterproductive. We're going to try and onboard lots of new users, and then we're going to tell them, hey, just as we talked about in the panel before, get your 15 wallets, here's 30 chains you have to manage, here's 50 chains you have to manage, go ahead and figure it out. That's just not going to work. And so my argument has been for the longest time, and of course I'm very biased because I'm building this thing, is that interoperability is the last layer of the modular stack, and really it's the one that completes it. Because it doesn't make any sense to talk about a world where you're going to have many rollups, right? 6, 7 figures of rollups, and you're not going to be talking about how they connect with each other, how they connect to chains outside their ecosystem, how this whole thing has any connectivity in such a way that we just didn't create an ocean of fragmented chains. But really, this is kind of an attempt to visualize this, right? Like, we have these few chains acting as hubs, and from them sprout more chains and more chains and more chains. And we're already today, we're in a world where there's well over 100 chains. And the pace of growth continues to expand, right? If you talk to any roll-up service provider, you'll see they have dozens of customers in their pipeline. Each one of those customers becomes a standalone chain. And so where we're headed for by the end of this year is a world of genuinely close to 1,000 layer 2s on Ethereum. Don't quote me on that number, but that's where it seems like we're headed. So you have to have a way for these chains to connect. It has to be permissionless. It can't be the case that each one of those chains need to go and need to file an application and need to basically wait on the good graces of someone else to do this for them. And for that, we built Hyperlane. So don't have enough time to get too into the weeds on what it is, but as I was saying before, Hyperlane is an open framework for interoperability. But if you take one thing away from it today, is that here's this thing. It's an open framework. Every piece of it is open source. I can use it, I can take it, and I can do what I'd like with it. I can customize it to my needs. In fact, if any of you here are developers and you're feeling kind of bold, you can go on our docs right now. You can download our CLI, and you can attempt to deploy Hyperlane to any chain you'd like, or even just test it locally and see for yourself. But really all it is a system that allows smart contracts to communicate between chains. At the core of it are our mailbox contracts. Think of this like as an on-chain API that you as a developer interact with. It's where any movement about assets, any bytes that you're sending between chains to initiate a function call on a different chain, that's where it would first get captured and encoded. Second, we have some security modules. These can take the form of anything that produces a state attestation or a state proof. So they could be as simple as like a lightweight validator committee, just people running the software, looking at a mailbox, saying, hey, John just sent a message from Ethereum to Solana. John just sent a message from Ethereum to Osmosis, and validating, signing off on that message, basically providing a state attestation. Or it could be as complex as using like a ZK proof. There's already been several teams that have been working on a ZK proof engine that have implemented theirs as a Hyperlane module. Most recently, we had the succinct module finalized, and this is the module that uses the succinct prover. Lastly, there's a relayer. Again, also open source. Think of it kind of like a bot that just sits between the chains, sees that your message is incoming, sees that you paid the fees, and then it processes it on the destination. And luckily, it also deals with the gas tokens, so you don't have to have any issues with that. So this diagram here is just an attempt to display how normally in interoperability, security and the messaging itself, those are tightly coupled, meaning that there tends to be just one security module. That everyone who wants to pass a message has to pass it through that module. And in Hyperlane, we've decoupled that. And that is what allows that capability that I mentioned before, is to leverage pretty much anything that provides a state attestation or state proof. These can take the form of economic security. Hyperlane's AVS will be going live soon, and after that we're just going to add staking modules to allow any chain to leverage any asset they'd like. It could be their own token, it could be a token of an ecosystem they're a part of. And so you'll see more and more modules. And so if you're a team that's very security minded and your product is a security product and you're having some trouble getting users, but you think that your product is very much worthwhile, come to Hyperlane, implement your product as a module, and I'll bet you that you'll see a good amount of usage going through your product. And so I'm not going to have time to talk about all this, but the key of what I wanted to get to today is this new product that we've launched, yield routes. And so in Hyperlane, the bridging concept is a little bit different than what you're used to from before. Normally, bridging is done in such a way where all the assets from all the people go into one contract, and as the bridge gets more popular, that contract becomes an increasingly attractive honeypot for anyone who wants to maybe take a little bit of money out of it. Don't recommend you do it, but you sure can. And warp routes are a bit different. With Hyperlane, we have this notion of modular security, being able to leverage external things to secure your interchain communication. And so due to that, warp routes, they're much more individualized. So it's one contract per asset, and instead of one contract for all the assets. What this lets you do is leverage the unique security properties that you get from Hyperlane. So the same chain could have two bridges going into it, one say for Ethereum and one for USDC, and it could secure those completely differently. And that's something you might want to do if one of those tokens is your gas token, if another is just a popular transactional token. And so what we've also seen in the realm of new chains, we've seen this notion of passive yield, sometimes called native yield. We've seen that being used very successfully as a go-to-market strategy. First with Blast, later with Manta. And you know, at Hyperlane, we built a feature that would allow you to do this sometime last year. Just thought, oh, this would be cool. And then no one really cared about it. No one wanted it, no one inquired, so we just kind of kept it on the shelf. And then Blast rolls around, December of this last year, and suddenly everyone's asking about it. So why am I telling you about this? Because now it's live. Now you could use this. And so the core of this was, with Hyperlane, we've taken something that would previously you had to go through a gatekeeper for, you had to talk to someone for, you had to do some convincing for, whether it was a business development process or more political process through governance. You had to kind of be opted into, you had to be enshrined by some interoperability provider. When it came to native yield bridging, you had to basically build it yourself because there was nothing in the market. And so what we've done for interoperability is made it accessible for everyone through our framework. And what we're doing now is we're making yield routes or native yield bridging accessible to everyone. And so these work very similar to how Hyperlane warp routes work today. One small distinction is that you have your warp route, it accepts assets, it'll mint those on any chain that you want to be as the destination. If you want that to be a token that can traverse between multiple chains, you can configure that as well. But now, those funds that got deposited into your route, into your bridge, they no longer have to sit idle. So in the warp route case, as is the case with the yield route, the deployer is the owner. It's not anyone at Hyperlane, no one. The deployer is always sovereign, the deployer is always the owner, and they really are the ones who control everything. And now in the case of these yield routes, they're also the ones who configure what to do with the collateral assets. So now at their disposal in this kind of, call it like V1 of this concept, any deployer can say, can pick any vault on the chain where they're taking the deposits from. So say if you're doing a route to your chain from Ethereum, any vault that's on Ethereum, that's on the 4626 standard, can be deposited into from this yield route. And so whether it's USDC, Ethereum, whatever assets the vault will take, you can use through this yield route. And then your users, as they deposit into your chain through this bridge, their funds automatically get sent into those vaults and start accruing yield. Now again, because this is kind of a V1 where we're doing mostly trying to figure out what the market really wants, trying to figure out how to land on this, what we're seeing for the most part is that the owners want to keep the yield and then decide what to do with it. And so right now, if you use this for your chain, users don't automatically get the yield. When they redeem, they get back their initial deposit, and any accrued yield stays with the owner. So what can the owner do with it? You can distribute it to the depositors as you see fit, basically. Take no part of it, just let them have it. You could keep all of it, use it as a new revenue stream. Or you could also use that to drive new activity on your chain. So maybe you're using it to subsidize gas, maybe you're using it for some like broader ecosystem incentives. Really the choice is completely yours. And so we're pretty excited to see where people take this. Like we didn't think that people would be using it for ecosystem incentives, but now a couple of the teams that are building with yield routes, that's what they're excited about doing. Not an idea that we would have thought ourselves. So that's the cool thing about systems like this. So running out of time, so we'll just, yeah. Anyways, that was Hyperlane and our yield routes. If you're building your own chain, definitely reach out. If you want native yield bridging, check out yield routes. We'll be here all week, and you can find us at hyperlane.xyz.